In this video, I want to talk about how to factor an algebraic expression by using its greatest common factor. So in this first example, I have 15x to the fourth plus 55x to the seventh. So I'm going to break this up into two pieces. I'm going to speak about the numeric piece first and then about the variable piece second. So between 15 and 55, numerically, what's the greatest common factor there? Well, 15 is 5 times 3, and 55 is 5 times 11. So I know they each have a 5 in there, but how about more values? Well, there's a 3 here and an 11 here, and they don't have a greatest common factor other than 1. So we know numerically the greatest common factor is going to be 5. Okay, how about with the variables then? Well, I have x to the fourth and x to the seventh. So you'll notice x appears in both terms. So we'll take the greatest common factor as the exponent that's the least. So 4 and 7. So the greatest common factor will be 5x to the fourth. Okay, so how can I factor this expression now using that greatest common factor? Well, basically it's just the backwards distributive property. So I'm going to factor out the x to the fourth, which means I'm going to divide it out of each of these terms. So 15 divided by 5 is 3, and x to the fourth divided by x to the fourth, well, that's just 1. So right here I just have 3. So, and then this addition problem, so this plus comes down. So 55 divided by 5 is 11. And then x to the seventh divided by x to the fourth. Okay, well maybe let's look at this over on the side. So x to the seventh divided by x to the fourth. So let's go ahead and write this in expanded form just so we can see visually what's going on. Okay, so you see the top has 7 x's and the bottom has 4 x's. So these will all cancel, and we're left with x cubed on top. And again, the quotient property for exponents just says if I'm dividing like bases, I can subtract their exponents. So 7 minus 4 is 3, and that's why that works that way. So here I'm going to say x cubed. So now I have factored this expression using the greatest common factor. And you can always kind of check it to make sure by asking yourself, well, are there any more factors that are common between these two terms? And if not, the other thing you can do is just go ahead and multiply it back out. So 5 times 3 is 15, and then we have the x to the fourth. 5 times 11 is 55, and x to the fourth times x cubed is x to the seventh. And you'll notice that's exactly what we started with. So we have factored this first example using the greatest common factor. In this second example, we have 3 terms here, negative 6a cubed b squared plus a to the fifth b squared minus a squared b squared. Okay, so one thing I'm going to tell you right off the bat is this expression leads with a negative, and it has actually 2 negatives and only 1 positive. So I'm actually going to factor that negative out. And we'll talk more about that in later videos when we start factoring and solving equations by factoring. Okay, so numerically we have coefficients of 6, 1, and 1. So I'm going to say numerically the greatest common factor is just 1. So I'm not going to bother putting that 1 out there. So let's talk about the a's next. So we have a cubed, a to the fifth, a squared. So every single term has an a in it, and the exponents are 3, 5, and 2, so the smallest of those is 2. So I'm going to say the greatest common factor will be a squared as far as the a's are concerned. Now how about the b's? Looks like we have a b in every single term, and they're squared, squared, and squared. Well, they're the same. So a squared, b squared with the negative is going to be my greatest common factor of these 3 terms. So when I divide each term by the negative a squared b squared, that's what I'm going to write in the parentheses here. And again, it's kind of backwards distributive property. So the negative divided by the negative is positive. 6 divided by 1 is 6. A cubed divided by a squared is just the a, because 3 minus 2 is 1. And the b squared divided by b squared is just 1, so we can ignore that. Okay, the positive here divided by a negative will make this negative. And the a to the fifth divided by a squared, 5 minus 2 is a cubed. And then b squared divided by b squared is just 1, so we'll leave that alone. Finally, a negative divided by a negative will be a positive. A squared divided by a squared is 1. b squared divided by b squared is 1. So it looks like just 1 there for the last piece. So I'm going to say I have factored this completely using the greatest common factor here. So, as kind of a quick check, between 6a, a cubed, and 1, are there any other factors that we've missed? Well, no, because this guy's a 1, so we haven't missed any factors. So let's go ahead and multiply it back out and make sure that we have done it right. So negative 6, a cubed, b squared, okay? Negative and a negative makes positive, and then a to the 5th, and then b squared, and then positive and a negative makes a negative, and then 1 times that, of course, is just going to be that. Okay, so what does this look like? Well, it looks like exactly what I started with. So negative 6a cubed b squared plus a to the 5th b squared minus a squared b squared. So I know I have factored this using the greatest common factor correctly. In this last example, we're going to go ahead and factor this expression using the greatest common factor. So here we have 4 terms, so let's deal with it numerically first. So 24, 12, 30, and 18. And maybe you're not sure, or maybe there's a lot of terms here, so we kind of need to come over to the side a little bit and work this out. So 24, 12, 30, and 18. So what's a factor that will come out of all those? Well, they all look even, so let's divide a 2 out. So I'm left with 12, 6, 15, and 9. So are there any factors that are common to all of these? Well, it looks like 3 will come out. So 4, 2, 5, and 3. But 2, 3, 4, 5, definitely no more common factors there. So our greatest common factor numerically is going to be 6. Okay? So let's go ahead and write that 6 out here. And how about the rest of these terms? We have m's in every single term. So m to the 6th, 5th, 4th, and 6th. So 4 is the smallest. So we'll say 6 m to the 4th. And there's an n, but there does not appear to be an n in every single term. So I'm not going to have a greatest common factor that includes an n. Okay, so this is where we are right now, 6m to the 4th. And I'd like to divide that out of all 4 of these terms. So 24 divided by 6 is 4. M to the 6th divided by m to the 4th is m squared, and then n squared, because there was not an n that we were dividing out. So minus 12, and 12 divided by 2, or 12 divided by 6 is 2. And then m to the 5th divided by m to the 4th is m, and then that's all there. So plus 30 divided by 6 will be positive 5, and m to the 4th divided by m to the 4th, well, that's just 1, so we have our n. And finally, negative 18 divided by 6 will be negative 3, and m to the 6th divided by m to the 4th will be m squared. And no n's on that last term, so we know we're good. So we have factored this expression using the greatest common factor. So we saw that 6 was the greatest common factor between all these coefficients, and then m to the 4th was the greatest common factor as far as the variables were concerned. And once again, we can, of course, go ahead and distribute this back through and just verify that it works. So 6 times 4 is 24, m to the 6th n squared, which that's the first term, minus 12 m to the 5th, and that's this term, plus 30 m to the 4th n, so 30 m to the 4th n, and finally negative 18 m to the 6th, which is the last term there. So there's kind of an introduction to factoring algebraic expressions using the greatest common factor.